In this video, we will review how to adjust exposure techniques. The first step in understanding technique is to know what happens to the overall exposure of the image when the KVP is either increased or decreased. We use the 15% rule to understand what a change in KVP does to the overall exposure. A 15% increase in KVP results in approximately 100% increase in the overall exposure, or double the overall exposure. Conversely, a 15% decrease in KVP will result in approximately a 50% decrease in overall exposure, or 1/2 the overall exposure. Knowing this rule comes in handy when selecting exposure factors. This is something you should be able to do quickly in your head in order to make quick decisions about selecting your techniques. A patient doesn't want to wait on the table for you to grab a calculator or paper and pencil to make some calculations. So what do these changes do to the image we see on the screen? Probably nothing. The computer software compensates for over and under exposure well enough that unless your exposure is very low, that information is missing because not enough x-rays reach the image receptor, or so high that so many x-rays reach the image receptor that is completely saturated, the image will appear adequate. Visually, it'll be fine. But we will talk more about this later. So let's look at an example together using fictional numbers. A hand is performed at 56 kVp at 4 mass, and we want to double the overall exposure by adjusting the kVp setting. The first step is to find out what 15% of 56 is. And to do that, we take 56 kVp and multiply it by 15%, or 0.15. And that answer is 8.4 kVp. Next, we add the 15%, or 8.4 kVp, to our original number, which was 56. So 56 plus 8.4 kVp equals 64.4 kVp. And we would round this to 64 kVp. You always want to round your kVp settings since these are not selected in a fraction. So that would mean that our new exposure would be 64 kVp at 4 mass, and this is twice the overall exposure as our starting exposure of 56 kVp at 4 mass. So this is an example of how we could adjust the kVp. Next, we will look at adjusting the mass. If you were to increase the mass by 100%, this will result in a 100% increase in the overall exposure, or double the exposure. A decrease of 50% in mass will result in a 50% decrease in overall exposure, or 1/2 the exposure. So it's proportional. It is important for technologists to understand that as they increase the mass, they are increasing the radiation dose to the patient. It is a proportional relationship in that when you are doubling the mass, you have now doubled the amount of radiation the patient is receiving. Let's look at an example in adjusting the mass, again using made-up numbers. If a hand is performed using 64 kVp at 4 mass and we want to decrease the overall exposure by half by adjusting the mass, we need to take our starting MAS of 4 and divide it by 2. This would equal 2 mass. Our new exposure would be 64 kVp at 2 mass, and this is half the overall exposure as our original exposure of 64 kVp at 4 mass. 64 kVp at 2 mass is the same exposure as 56 kVp at 4 mass. Why is this? A 15% increase in kVp doubles the overall exposure, and cutting the mass in half decreases the exposure by half. The two acts cancel each other out, maintaining the overall exposure. And we can use this in order to manipulate our techniques. We can use the minimum kVp and lower our mass to decrease patient dose. So let's recap what we have learned. We need to remember that digital systems are more effective with higher kVp settings, and that using higher kVp allows us to decrease the mass. By lowering the mass, we are decreasing the radiation dose of our patients. We should also know that quantum models should be avoided. We should know what it looks like and be on the lookout for evidence of quantum model on our images. We also need to know the rules to modify kVp and mass like the back of our hand. This should eventually become second nature to us so that we can make good, quick decisions on the floor based on the calculations we've made in our head.